What up, what up? It's your man, Jimmy Chan. All right, so today we're talking about combinations and composite of functions. So let's first talk about combination of functions. Well, that's where you're going to have sum, difference, product, and quotient. Well, what you're going to see and what it means, once you see it, what it actually means, then you're going to be like, okay, I can make sense of that. So the first one, the sum, you're going to see like f plus g of x, okay? All that means is find f of x, find g of x, and add them together, all right? In terms of difference, you might see this. Well, all that means is find f of x, find g of x, and subtract them. And it's going to stay in order, so in case if you see g first, then that means you got to find g of x first, then f of x, and subtract in that order, okay? So obviously you're noticing that we're getting two different functions here, right? The f of x and the g of x, and we got to add them together or subtract them or multiply them or divide them, okay? So let's go ahead and keep on going. So you might have f dot g of x, meaning f times g of x. So that's just going to say find f of x, find g of x, and multiply them. And then you're going to have f divided by g of x, which just means find f of x, and divide that by the g of x. Okay? And then in terms of composite, those are slightly different, right? It's not any of those operations. It's actually more of an order. And if you notice that it almost looks like I'm spelling fog because there's an open circle in the center, do not mistake that with a product, okay? So you actually see like an open dot. That's what composites are. So what does this actually mean? This actually means find g of x first, then plug it into f of x. So this says to find g of x first, okay? Actually, let's first find g of x, use that result in f of x, okay? You're like, well, what does that really mean? Okay, well, let's do an example. So for example, let's say they give, so given that f of x is, I don't know, negative x squared plus 2x minus 1, okay? And they say that the g of x is equal to x plus 1, all right? So let's say they go, okay, so I want you to find f of g of negative 2. Okay? All right. Well, actually, let's make it even more. Let's make it negative 3. Okay? So if that's the case, what this is telling me that this is equal to f of sorry about that. F of g of negative 3. Okay? So in other words, I'm looking for the g of negative 3 first. Then I'm going to plug that into f of x. So I need to find, oops. Okay, so I need to find that first. So let's find g of negative 3. Well, g of negative 3 would equal to -3 plus 1, right? Where the x is replaced with -3. So g of -3 is equal to -2. All right, cool. So that means all I got to do now is replace that g of -3 with a -2. So now I'm finding f of that -2. Better yet, let me say it this way. The f of g of -2 would equal to f of wow, brain not working so well. There we go. So if since I'm looking for the f of g of -3, that's the same thing as saying f of -2. So now I'm going to do f of -2. Great. So that's going to equal to what? That's going to equal to -2 squared plus 2 times -2 and then minus 1. Okay. So what do I have here? I have -2 squared, which is 4. Negate that, so -4. I have 2 times -2, which is -4, and then minus 1. So the f dot g of -3 would equal to -9. And there we go. Okay. So think of this as two parts, right? We're working on the inside, and then we're working on the outside. Okay. All right. So with that being said, so the important part about this is that when we are doing the combinations, there are times that we're going to be able to simplify, right? And there's times that we're not going to be able to simplify. And the examples that I'm going to do, we won't be able to simplify most of them, okay? However, what we will be asked for, however, is the domain, okay? And the domain was all the possible values that we can put into that expression, okay? So all possible values we can use in an expression or equation. Okay, so what are some of the things that we need to worry about? Well, one of them would definitely be fractions, right? So this is something that you should have done before. So if I had a fraction a over b, what I know is that b cannot equal to 0. Because if b was equal to 0, then that fraction would be undefined, right? So if I look at in terms of domain, if it's just b can't equal to 0, b can be anything else, right? It could be anything that's less than 0. It can be anything greater than 0. So that means the domain here is going to be -infinity to 0 without including 0. That's why it's parentheses, union with 0 to infinity. Okay? Now that's just for b. So let's say, for example, if I had 1 over x plus 2, right? I know that x plus 2 cannot equal to 0. So that means if I subtract 2 from both sides, then x cannot equal to -2, right? But it can be everything else. So in this case, the domain would be that it can be anything from -infinity to -2, but not including that, union with -2, not including -2, all the way to positive infinity. Okay, so This is just a general statement that the denominator has to be from negative infinity to 0, not including 0, union with from 0 to infinity, not including 0. But each problem is going to be a little bit different because we may have to adjust because of what we're given as a denominator, okay? So the other one that we're going to have some issues with is going to be radicals, okay? And specifically, we're talking about eventh roots. Those are where the index is even, okay? Meaning like a square root, fourth root, sixth root, eighth root. And the issue with that is that with those even roots, like the square roots, I can't take a square root of a negative number, but I can take the cube root of a negative number, right? But I can't take a square root of a negative number. So that's where I gotta be careful of, right? So let's say I have the square root of b, right? In this case, b can only be greater than or equal to 0. It can be 0, and it has to be greater than 0, but it can't be less than 0, right? Because if we have less than 0, then we're talking about negatives. So b cannot be a negative number. So therefore, in this domain, I'm saying that what I have is negative, no, I can't have negative infinity. So therefore, I can only go from 0 to positive infinity, okay? I can't go anything less than 0, but it can be equal to 0. However, if I had an example, trying to see my spacing here, that's pretty good. All right, so for example, let's say I got the square root of x minus 4, okay? So what I know here is that x minus 4 has to be greater than or equal to 0, right? So the way I deal with inequalities is I would add 4 to both sides. So x has to be greater than or equal to 4. So for this example, my domain would be right? Anything from 4 and above, including 4, right? So if I put if I put 4 in this example, right, I'll have 4 minus 4, which is 0. Square root of that would be 0. If I can put 5 in there, right? 5 minus 4 is 1. Square root of 1 is just 1, right? I can do square root of 2, square root of 3. That's no big deal. I just can't use a negative number. That's why it has to stop at 4 and then going up, okay? So again, this is just a general statement in terms of the domain being going from 0 to infinity because the inside of the house or the B is the only thing in there, right? But once the insides change, we're going to have to adjust that domain a little bit as we go, all right? All right, so let's take a look at some examples in terms of what are some of the things that we're going to see with these combination and composites, right? So for example here, let's say it tells me that f of x is equal to square root of x, and g of x is going to be x squared plus 2x plus 1, right? And we notice that in terms of domain-wise, the g of x doesn't really have anything that we need to be concerned about, right? We can use anything from negative infinity to positive infinity in this case, right, in terms of this domain. While the domain here for the f of x is more about that x has to be, 0 or above. Okay, so that's the way we want to look at it. Okay, so if I was to do, let's say, the f plus g of x, which means I gotta find f of x plus g of x. So let's say I do the square root of x plus x squared plus 2x plus 1. So what would be my domain here? Well, I don't really have a concern there. It went from negative infinity to positive infinity, so that was negative infinity to positive infinity, okay? And then over here with this, I have it going from 0 to infinity, okay? So I would want to take the intersection of these two. And you guys remember intersections. Let's say 0 is here, okay? So for the red domain, I'll go from negative infinity to positive infinity, while the square root here is going to go from 0 to infinity, right? And in that case, and this is going to be a closed circle here, right? All right, so in this case, intersection is what they have in common. Well, what they have in common here would be this part right here, right? Everything from 0 all the way to infinity. So therefore, the domain here would be from 0 to infinity. Okay. Let's do, let me see here. Let's do if this was a division. Okay. So let's say I have f divided by g of x, right? Well, that's going to be f of x divided by g of x. Okay. So my f of x is square root of x over x squared plus 2x plus 1. Ooh, ooh. So now, can I simplify this? I cannot, but I do need to find the domain, okay? Now, the good news about this is that I could simplify the denominator. So I know that this denominator, actually, let me do it this way here. I know this is supposed to be in red, so I'm going to say, okay, the domain here is that x squared plus 2x plus 1 cannot equal to 0, right? Okay. The cool part is that this is actually factorable, right? So I can actually factor this. This is going to come up to be x plus 1 times x plus 1 cannot equal to 0. That means x cannot equal to negative 1, okay? So that is actually my, my restriction, which will help me with my domain. So it can't be negative 1, but can be anything else. So that means my domain here, just for the red, is going to be negative infinity to negative 1, not including negative 1, union with negative 1 to positive infinity, not including negative 1, okay? And then up here on top, right, I know that, well, that's a horrible arrow. So the top, I can say that x has to be greater than or equal to 0 still, right? So that means my domain here is still going to be 0 to infinity. Okay? All right. So what does that look like as my domain? So let's go ahead and grab that line again. And okay, and here is 0, here is negative 1, let's say, okay? So what's going to happen is the red is going to look something like this. Kind of look like this. Now, I have not done yet, okay? So, it's Vunk. Okay, so there's an open circle at negative 1, but it can be anything else. Okay, so what's the blue going to look like? The blue is still going to look like from 0 over. Okay, so, but it can be 0. So what is the intersection here? The intersection is still this part right here, right? Everything from 0 and above. So therefore, my domain here for the whole problem wow. So my domain for this particular problem is going to stay as 0 to infinity. Okay, you see that? All right, so yes, you're right. The domain on the bottom, it cannot be -1, but the restriction up top is going to be even more strict. All right, so we're going to go with a stricter. Or if you look at the intersection of those two, then that's what we would have. Okay, so I should probably box the domain for you guys just so that you guys know what the answer would be here. Boom, boom, okay? All right, so what about the composite? So I did two of the combination. Let's do composite. So let's say I have f dot g of x, right? Which is the same as saying f of g of x. So let me do this here. Okay, so in other words, what's g of x? Well, g of x I already know, right? G of x is x squared plus 2x plus 1. So that's exactly what I'm going to plug in there. So this is going to say f of x squared plus 2x plus 1. Okay, so the f was square root of x, so therefore this is equal to the square root of that whole thing, right? Great. So that is what my answer would be. However, if you notice that, again, this inside here is factorable. So that is actually x plus 1 times x plus 1. So really speaking, this actually simplifies. So I really have the square root of x plus 1 squared. Ooh, look at that. What happens when I take the square root of a square? That's right. So what I'm going to actually have left is x plus 1 as my answer. Okay, so let me put it this way so that I can write the f dot g of x is equal to that. Okay, so that's my answer. But what is my domain? Correct. It would be negative infinity to positive infinity because my radical went away, right? Initially, I was saying that inside has to be greater than or equal to 0. Well, the thing of it is it's squared. So if you look at just this piece right there, it's telling me x plus 1 squared. Well, I can throw any negative numbers in there, and plus 1 is still going to be negative, right? And that square is going to become positive. So then I can take a square root of it. So any of those things can happen. So if you look at my result being x plus 1, really I don't have a radical, I don't have a fraction, I'm good to go. So therefore my domain would be negative infinity to positive infinity, or we also know this as all reals. Okay? All right. So hopefully this helps. If they have any questions, let me know. Oh, the other part that they're going to talk about is going to be doing this with graphs. All right. So, but we're going to end this part right here. See ya. Bye.